Welcome to the deep dive. Imagine a digital gold rush, but instead of striking gold, you're trying to build the mines and the power plants faster than anyone ever has before.
Yeah, that's a good way to put it.
That's really the unseen battle happening right now in the world of data centers, the very bedrock of our AI-driven future. Today, we're plunging into the core of this transformation, kind of extracting the crucial insights and, frankly, surprising facts from a stack of sources that paint this astonishing picture. An unprecedented boom in data center development was entirely driven by the explosion of artificial intelligence.
And unprecedented really is the key word here, isn't it? Our sources highlight that the global AI market, already valued at, $279 billion, roughly, in 2024,
Right.
It's projected to skyrocket to $1.81 trillion by 2030. That's a compound annual growth rate of nearly 36%. This level of spending in just the past 2 years on facilities supporting digital innovation is, well, it's just without historical parallel. But what's fascinating here, and this is the real tension, is that while this growth is immense, it's hitting some very real limits.
Okay, so the scale of investment is clear. Huge numbers. But what does this mean on the ground, like for the actual infrastructure that's supposed to support this digital revolution?
Well, what our sources reveal is pretty stark. Digital infrastructure, specifically data centers, it's the only segment in the entire commercial real estate landscape currently experiencing a structural boom.
The only one?
The only one. This isn't just a fleeting trend, it's a foundational shift.
That's an incredible statement, a foundational shift. And the financial activity certainly seems to back that up.
Oh, absolutely.
In 2024 alone, we saw over $5 billion in merger and acquisition volume. That's up, 88.5% from 2023?
An astounding jump, yeah.
And it's not slowing down. Our sources estimate $29 billion in M&A deals are already agreed upon for 2025.
Which shows tremendous investor confidence, yes, but it also signals this rapid consolidation. It hints that the future of digital infrastructure might be controlled by, an increasingly concentrated few.
Right.
It's fundamentally reshaping the competitive landscape. Forecasts indicate that these hyperscaler-owned facilities, think Google, Microsoft, Amazon.
The big players.
Exactly. They'll comprise over 40% of data center capacity by 2030. That's a huge jump from below 25% right now.
So a few giants owning a really significant share. What about how these massive projects are actually being funded? Are we seeing traditional banks stepping up, or is the money coming from new places?
We're seeing a really fascinating shift in the financing trends. There's definitely a deep and growing lender pool, yes. Asian and European project finance banks are leading the way for the big investment-grade hyperscale build-to-suit opportunities.
Okay.
But crucially, you've got private credit and alternative insurance capital stepping in. They're supporting the non-investment grade AI customers like CoreWeave, Lambda Labs, OpenAI, Crusoe.
The newer, fast-growing AI companies.
Exactly, the ones rapidly expanding their capacity requirements. And these alternative funding sources, they offer more flexible, more borrower-friendly structures.
Which they need, right, for that speed and scale.
Absolutely crucial for these companies that are just exploding in growth.
And operators are getting creative, too, with these capital recycling programs. Selling off older assets to fund new ones.
Yeah, selling off their stabilized, established assets to pour that capital right back into new development. It further fuels this incredible boom. It's almost like a self-sustaining cycle of investment right now.
Okay, but this explosive growth, this almost insatiable demand for AI, it isn't happening in a vacuum. You mentioned limits earlier. What exactly are these fundamental barriers that this whole boom is running headlong into?
Right. The primary limitation straight out of the gate is power. Just sheer electricity.
Okay.
What our deep dive into the numbers shows is that U.S. data centers, both existing and planned, are going to demand about 30.7 gigawatts of power.
30.7.
But here's the catch. The utilities, they're only set to supply about 20.6 gigawatts.
Whoa.
That's a massive 10.1 gigawatt shortfall.
10 gigawatts missing. That's huge.
It is. And what's more, utility capacity upgrades aren't quick fixes. They take years. You're looking at maybe up to 9 years in California, 7 in Northern Virginia, and a staggering 12 years in Ohio.
12 years. 9 years in California, 12 in Ohio. That's almost a decade or more just waiting for the power grid to catch up to today's demand.
Exactly.
It really puts the scale of this problem into perspective, doesn't it? And AI workloads themselves aren't like traditional computing, are they? They use power differently.
That's a critical point. They create these unconventional load profiles. They pulse, from maybe 10% auto 1 second to 150% overload the next.
Wow.
And that demands not just huge amounts of power, but continuous, consistent power for cooling those intense bursts.
Right, you can't let them overheat.
Absolutely not. So to address this, data center operators are exploring several strategies. A significant chunk, 62% of surveyed professionals, said they would actually delay data center openings until utility capacity is available.
Just wait.
Just wait. Other options include connecting directly to low-carbon firm power sources, like nuclear plants behind the meter.
Meaning they bypass the public grid.
Essentially, yes. For a more dedicated, reliable supply. About 40% are considering that. Or even more drastically, canceling new builds altogether. That's something 38% would consider.
That's pretty serious. Are there any on-site solutions, things they can build right there to bridge this power gap?
Yes, definitely. Operators are deploying on-site power generation solutions. There's bridge to power, which helps them get online faster by supplying energy temporarily while they wait for the permanent utility connection.
Oh, okay.
And island power, which creates these self-sufficient microgrids for crucial operations. These can use everything from fuel cells, battery energy storage systems, BAS and solar PV for smaller needs, maybe tens of megawatts,
Right.
all the way up to turbines and engines for larger demands, getting into the hundreds of megawatts.
Okay, so there are options, but it sounds complex and expensive. And even if we could miraculously solve the power puzzle tomorrow, we immediately hit another critical bottleneck, the specialized hardware needed to run these AI factories. As NVIDIA's CEO Jensen Huang famously said, AI is not a chip problem, it's a reinvention of computing problem. He said you can't solve it just by designing a chip, that every aspect is fundamentally changed. With that context, what does our research tell us about the actual chip situation?
Yeah, he's spot on. Modern AI relies so heavily on graphics processing units, GPUs, for that massively parallel processing it needs.
Right.
And NVIDIA is, well, they're the undisputed market leader in these cutting-edge AI chips. TSMC, the Taiwanese semiconductor giant, is the exclusive fabricator for NVIDIA's most advanced H100s, which leads directly to long waiting lists. And you have to consider the cost. Building a single one of these chip fabrication facilities, a fab, today costs upwards of $20 billion.
$20 billion for one factory.
Exactly. That creates these significant choke points in the global semiconductor supply chain.
So with these choke points at TSMC, how are the major players, the cloud providers, responding? Are they just sort of waiting patiently in line, or are they trying to find other ways?
That's a great question. We're seeing exactly what you'd expect. Major cloud providers like Google, Microsoft, Amazon, they're pouring resources into developing their own proprietary chips.
Ah, interesting.
Think Google's TPUs, Microsoft's Athena chip, Amazon's custom inference and training chips. They're doing it precisely to reduce that reliance on NVIDIA and, gain a competitive edge by optimizing chips for their specific AI workloads.
Makes sense. And then there's the perhaps less glamorous, but equally critical, maybe even the ugly side of this boom.
Yeah.
The talent crunch. The people problem.
You're absolutely right. It's huge. The construction industry, just as one example, faces a nearly 500,000 job deficit nationwide.
500,000 jobs.
Yeah. So data center development is competing for this finite pool of skilled labor against other massive projects, like all the new manufacturing facilities being built. And our sources point out that organizations often shortchange their greatest resource, their people.
How so?
By focusing almost solely on the new technology, the hardware, the software, and not enough on training and upskilling their workforce, this leads directly to skills gaps, which ultimately result in slow progress and elusive ROI.
So it's not just about silicon and megawatts, it's about actual human beings, skilled workers. It sounds like if we don't fix that talent gap, all these other cutting-edge innovations might just sit on the drawing board gathering digital dust.
That's a real risk.
It really underscores this critical need, doesn't it? If we don't invest in our people, in professional development, and also in smart IT governance to manage all this, well, all this cutting-edge tech might just sit idle. But it's not all doom and gloom about overcoming problems. There's immense innovation happening too, right? The industry is finding new ways to build, design, and manage these powerhouses, really pushing the boundaries.
Indeed. We're seeing some really exciting advancements, particularly in sustainable construction. They're innovating with materials like green concrete, which is often made from industrial waste products.
Like what?
Things like fly ash from coal plants or silica fume from silicon production, and using steel slag, another industrial byproduct, as an eco-friendly replacement for natural aggregates like gravel.
So using waste to build the future.
Exactly. It's not just about being green for the sake of it. It dramatically slashes the carbon footprint of construction,
Yep.
and it finds scalable, sustainable ways to build these massive facilities. They're also tackling impact on land, particularly agricultural land, by suggesting things like permeable pavements around data centers to help manage stormwater runoff naturally. Although it's worth noting, those do have a lifespan limit.
Okay, interesting. And the design itself is becoming far more sustainable too, not just the building materials.
Absolutely. Innovations include things like incorporating underfloor air distribution for more efficient cooling, energy recovery wheels that capture waste heat, and even ice storage systems into the HVAC to kind of smooth out energy use.
Ice storage, how does that work?
You basically make ice during off-peak hours when electricity is cheaper or cleaner, and then use the melting ice to help cool the facility during peak hours.
Clever.
Yeah. And they're also using economizers, more systems that draw in cool outside air when conditions allow, potentially reducing mechanical cooling energy consumption by up to 25%.
25% is significant.
It really is. And maintenance is also seeing huge improvements. We're talking about advanced liquid cooling systems becoming more common and thermal energy storage, similar to the ice concept, to reduce peak electricity usage and integrate more renewable energy sources better.
And liquid cooling is becoming essential, right?
Yeah.
Because the servers themselves are getting so much more powerful and dense.
Exactly. High-density racks are projected to reach up to 1 megawatt per rack by 2031.
1 megawatt in a single rack.
Yep. That kind of density absolutely necessitates these advanced liquid cooling solutions and also really high-capacity power distribution systems like these overhead rigid busways. Think of them as heavy-duty power lines running above the servers, delivering immense power directly to these ultra-dense racks without all the usual cable clutter under the floor.
That's a fascinating leap in design, just physically arranging things differently.
Yeah.
We're also seeing the emergence of this AI factory model. What's that about?
It's essentially about centralizing the expertise, the people, the processes, the tools for developing, deploying, and scaling AI solutions more effectively. It acknowledges that, really, no single player in the space has all the answers.
Right.
Which leads to this crucial need for strong partnerships across the entire ecosystem. You need the chip developers talking to the power managers, the software vendors working with the cloud providers. Everyone has to collaborate.
Makes sense. And what about this data center neutral carrier model? That sounds interesting.
Yeah, that's another fascinating development. It offers flexible connectivity that isn't tied to one specific data center operator. As enterprises pursue multi-cloud strategies using different clouds for different things or workload repatriation.
Which is moving stuff back from the public cloud.
Exactly. Moving data and applications back to private data centers for more control or cost savings or whatever reason. This neutral carrier model gives them more flexibility and makes it easier to switch providers if needed.
And alongside all this innovation, there's also growing concern, and maybe more action, around just protecting this critical digital infrastructure, right?
Definitely. You see things like the formation of the UN Submarine Cable Advisory Group. That's specifically to improve the resilience and repair of these vital undersea cables, especially after incidents of suspected sabotage and, natural disasters that have cut connectivity.
Yeah, those cables are surprisingly vulnerable.
They really are. And on a corporate level, companies like Meta are reportedly considering a massive, maybe $10 billion project to lay their own worldwide cable networks, partly perhaps to sidestep some of the geopolitical tensions involved with shared infrastructure.
Which brings us neatly to the next point. This isn't just about technology and construction specs. It's a global game with really significant geopolitical stakes, shaping economies and international relations. Our sources suggest a particularly strong trend here in the U.S.
That's right. There's a noticeable MAID in the USA trend emerging. It's largely driven by recent supply chain volatility. Think the pandemic shortages and federal incentives like the Cheap Chicks Act, pushing for reshoring critical industries like semiconductors.
This is bringing manufacturing back.
Exactly. We see companies like TSMC and Samsung investing tens of billions of dollars to establish advanced fabrication plants right here in the U.S. The goal is to secure supply chains and protect intellectual property.
But it's not a complete shift yet, is it?
No, not entirely. It's worth noting that even some chips fabricated in these new U.S. plants are still being sent back to places like Taiwan for the final packaging and assembly steps.
Yeah.
So a fully independent U.S. supply chain isn't quite there yet. It's complex.
This whole global push for control and capability also shapes how we even think about AI itself. While we often hear AI called the new electricity, our sources suggest that analogy.
Oh.
It has some critical cracks.
It really does. Right now, AI doesn't fully resemble a public utility. It still lacks standardized generation. Everyone's building models differently. It lacks a truly scalable distribution network, like the power grid. And it lacks a universally reliable interface.
So it's more like?
It makes it more of a brilliant, world-changing prototype, perhaps, but one that's currently, you could argue, over-centralized, energy inefficient, and built on brittle logic. Not quite the robust, ubiquitous utility that electricity is yet.
That potential fragility seems amplified by the fierce competition and the regulatory scrutiny that's starting to ramp up in the AI compute market. We hear about these massive deals and investments.
Right.
What's driving that intense competition?
Well, cloud service providers are giving incredibly deep discounts and sometimes even equity investments to AI labs.
Why?
It's driven by this intense race to gain market share, certainly, but also, crucially, to get access to the valuable data those labs use and generate. Data is the fuel for beta AI models.
And regulators are noticing this.
Oh, yes. Regulators, like the FTC here in the U.S., have already intervened in major mergers. NVIDIA's attempted acquisition of ARM is a prime example. They cited concerns about market concentration and the potential harm to future innovation if one company controlled too much.
And it gets even more complex when you think about the data itself. Does having exclusive access to these vast data repositories, Google with YouTube and Gmail data, Microsoft with all its enterprise services, AWS with its massive cloud footprint, give them an unfair advantage?
That's the big question. It certainly gives them a significant differentiator for AI model quality. And it raises serious questions about whether simply utilizing all that user data for AI training constitutes anti-competitive behavior, especially when smaller players just don't have anything close to that kind of data access.
A tough question with no easy answer.
Absolutely. And we're also seeing differing views emerge even within regions, like in Europe, regarding the right AI data center strategy. Some leaders, like SAP's CEO Christian Klein, advocate for focusing primarily on developing AI software applications and basically leveraging the existing hyperscaler infrastructure built by, the U.S. giants.
Piggybacking on their investment.
Essentially, yes. While others in Europe emphasize the need for substantial European infrastructure investment to maintain technological sovereignty and avoid becoming too reliant on non-European providers. It's a debate about control and independence.
So we've covered this incredible scale and speed of data center development, all driven by this seemingly insatiable demand for AI. But we've also dug into this really complex web of challenges, from finding enough power and getting the advanced hardware to sourcing the skilled labor and navigating these tricky global geopolitical dynamics.
Yeah, if we try to connect all this to the bigger picture, the journey of the data center industry right now really is a high-stakes balancing act. It's about trying desperately to meet this insatiable demand for AI capability.
While navigating unprecedented resource limitations, especially power. It's about securing a very delicate global supply chain for things like chips, addressing critical environmental concerns about energy and water use, and doing all of this while racing against the clock because the AI development isn't slowing down. Yeah. What stands out most to you about this really complex, unfolding story?
It really makes you wonder, doesn't it? Will this relentless drive for AI innovation ultimately force us to create a truly decentralized, maybe more sustainable digital infrastructure? Or will the existing bottlenecks, the power limits, the chip shortages, the market concentrations lead to an unforeseen future where this incredibly powerful technology remains largely centralized, maybe even more fragile than we realize? Something definitely to keep watching.